Hello, hello. Welcome back. Let's continue reviewing our textbook, Drafting and Design for Architecture and Construction. This video will be about our chapter 5 of the textbook. Again, this is just the supplementary material. You really need to go to the textbook and read that and see the images, see all the graphics and all the beautiful representations there. So chapter 5 is Introduction to Computer-Aided Drafting and Design, or CAD. And here we will learn the different kinds of CAD hardware and software and their functions. Then we'll learn the basic CAD drawing commands and learn how a CAD system is used to create architectural drawings. So as you already know, our technology is developing really fast. And by the time this video is out, it will be outdated. So, and you know that now the industry standard is Revit. So it's not even AutoCAD like it was a few years ago, although some of the engineers and some of the consultants still use CAD as their default program. But architects, for the most part, they switch to the Revit or some of the parametric architecture firms, they do that in Rhino with different plugins. But today we're going to talk a little bit about CAD. It will be very brief. It just, for you to know what that is about and to get familiar with the system. So CAD stands for Computer Aided Drafting and design, and it is a process through which architectural and engineering drawings and documents are prepared on the computer. So it started back in the day, back in the early 80s, 1980s. It was a very dramatic, large change in the whole architectural drafting system because it was done by hand, and now, like all of a sudden, you can connect the lines, connect the dots, and draw the lines on the computer, which was the revolution. And a lot of people were hesitant to use that. And it reminds me of like how some people still deny AI these days, but here we are, like it's here to stay. So the CAD characteristics, let's go through that real quick. So a drawing prepared using a CAD system should appear identical to a good quality drawing prepared manually. That's the main part. You need to be able to read the lines, you need to be able to interpret the drawing on the construction site and build according to those conform documents. So a computer-aided drafting system is an electronic drafting tool that uses the speed and accuracy of a computer to produce clear, accurate, and consistent drawings. So um, through electronic transmission of files such as PDFs, JPEGs, bitmap, or TIFF files, CAD drawings can be sent and received in minutes by clients and other professionals. So, and that speed in the design process ensures consistency in communication. So now even, authority having jurisdictions accept all the construction drawings electronically. They check them, they provide the comments, and they redline them in Bluebeam or other programs, and then they return back to if you need to change anything or amend anything. So, and the ease and speed with which drawings can be electronically stored and retrieved result in fast, clear, and accurate changes and revisions. And this is accomplished through the use of editing functions and allow drawings to be quickly deleted, redrawn, rotated, mirrored, stretched, and otherwise manipulated electronically. So first of all, now the exchange of the information is so rapid, and we need to catch up with that. So that actually is a good tool in our toolbox just to know how to do that. So CAD systems function via interactions among CAD hardware, software, and the operator. And the information entered in a computer is known as input. And a CAD drafter communicates with the computer through the use of input devices, usually a keyboard, mouse, and a cursor. And then when a drafter requests a specific function, such as a line, arc, or numeral, the operator that indicates specifically through a keyboard, grid system, mouse, or stylus pick where the line, arc, or numeral is to be placed on the monitor. So it's an advanced system, although now there are better 3D programs, the BIM, and we'll talk about that a little later, but let's go through a few different CAD components. So network systems are comprised of several individual computer stations that share a printer, plotter, and central processing unit, or CPU. And it's basically a large network system that is known as a mainframe. So please refer to the textbook. There are beautiful graphics that show you how to do that and like what is connected to what. So it's quite interesting to see. Although now we just do it intuitively, we just really don't kind of like break it down into the smaller elements. We just know how to operate that, right? It's, now it's the digital generation and we know how to do that. So as far as the input devices, it can be entered into the computer using various input devices, and that's the keyboard, and that's the mouse that we use to actually draw on the screen. And the output devices are monitors. Those are the temporary output devices, right? Because you can view that information on the monitor, and that is intended for use while at the computer workstation and in architectural work. So, but then you will, save the hard copy or a print, like when we send it to the printer, or we save it as the digital copy and we do PDFs, right? Like we plot to PDF and then we use the Bluebeam PDF and so on. So commands provide the link between the drafter and the software, and commands are used to activate specific CAD functions. Commands can be entered using a keyboard and a mouse, and usually a mouse controls a cursor or a crosshair pointer on a monitor. You know that. You know how that usually works on the monitor. And drafting commands, actually also known as tasks, are the commands used to create geometry. So individual geometric forms such as lines, circles, polygons, and so on are known as entities or objects. And most CAD programs have hundreds of commands, and we will not go through all of them because that's common sense. That's the lines, the polylines, the different, there are different actually types of lines. We already discussed that in the previous chapters. Then the arcs, that you can create an arc of any radius and any length, and that's the beauty of that. So you don't have to just have a giant piece of vellum to do that. You can just, do it to scale on the screen and then just zoom in and out. Then you can use text. You can use the text command. You can use the spline command to produce irregular curves. And then you can do the ellipse. You can do rectangles. You can do circles and other geometric forms, whatever you need to use for your specific drawing. Then you can use the polygon command, and it is all kind of like automated. Then there's a fillet, that's the small arc located on the inside of two intersecting lines after the line intersections are trimmed. So, and it's a nice command. You can just do it easily instead of manually, just kind of like making it shorter or longer. Also, you can do the chamfer that connects two lines and create like a cut-off corner. It's more like kind of just chamfered corner. That's what it is. You can create that. You can do the hatch. You can, just, and that is used to show the materials on, either floor plan or elevation or section. So that is a very nice tool, and there are tons of beautiful drawings here, and just what you can get with those commands. So there are CAD libraries, there are symbol libraries that provide designers with the most productive tool that is efficient and saves time. So, and you have those symbols, and they're either in plan, elevation, or pictorial form. So you can definitely utilize those. So also, there are some specifics that are used for different types of drawings, like for example, for the plumbing drawings, they have a series of lines representing pipes and other things. So, it's quite interesting if you really want to learn that. There are a lot of tutorials. You can even self-teach and just be efficient in that. There are LinkedIn Learning, there are different courses in Autodesk Academy and so on. So, and they're free. All you need to do is just dedicate your time and attention to that and just click your mouse around. It's not the rocket science. You can learn that. I will put together a separate video. It's not going to be attached to this textbook, but that'll be like about all the drafting systems that are popular now. I know that a lot of different AI systems and programs are coming in every single day, and it's hard to catch up with them, but I will try. So we'll try to do that. If you would like to hear more about that, let me know. Then there are a lot of other commands. You can move the object, you can copy, multiply, repeat, you can mirror the objects, you can rotate them, you can just, and you really can just play around whatever your needs are. There's a break command, the lengthen command, gap, or you can trim the element, you can redraw, and you can just really do different things with that. Then the zoom command magnifies or reduces the size of a drawing, but you can just do it with like by scrolling your wheel up or down. And you can pan, you can use the layer command, and that allows different segments of a drawing to be drawn separately and then combined into a single drawing. This is, I would say, like one of the most useful tools in CAD, in AutoCAD. If you just turn on and off those layers and just make sure that, if you want to just place all your FF&E or furniture, fixtures, and equipment on one layer, and then you can turn it off and you'll just see like a clean floor plan or something like that. So then there's the grid command that creates the, coordinate X and Y dots to be superimposed on the drawing. You can do that. Then there are ortho command. You can just orthogonalize, and that adjusts all lines to a vertical or horizontal position at 90-degree angles. So you can block, you can do the block command, and that allows access to combination of symbols or details, and you can just have like a block and you can ungroup them. You can do and manipulate that if you need that. You can scale, right? You can scale up or down. You can drag the elements. And of course, after that, all those iterations, you can save your work. And don't forget to click that save, that floppy disk often, because there is nothing worse than losing like 2 hours of CAD work or Revit work due to like a power outage, or just some things that happen with our devices. So yes, just have it as your good tradition just to click that diskette, that symbol, to save your work frequently. You can set up reminders to do that. You can just do it like every, like, let's say 15 minutes or so. Also, what you can do with CAD, you can, like I already said, that you can prepare it on a separate layer using the corresponding floor plan layer as the base drawing. And then you can, do different manipulations with the lines, like you can offset the line, you can do a polyline, you can do different things with that. And I'm not sharing my screen because I'm discussing the textbook, so it's best to see. So like, please be on the lookout for a different video where I will talk a little bit more about all these functions, and I will show it to you on the screen. That's the best way to learn it, like when you see it, and then you can repeat that on your own computer. So with CAD, you can create floor plans, elevations, sections, detailed drawings. You can do even the 3D drawings, but what is not good about that is you have to kind of like redraw things manually. When in Revit, you can actually change one thing. Like if you change the location of the wall or something, you update the materials or something like that, that will be reflected in all the drawings that will be created using that element. Like if you need to do the wall section, that will be actually shown, or if you need to do the interior elevations or exterior elevations, that will be definitely reflected. And that's the beauty of that BIM system. But we'll talk a little bit about that later. So here, in addition to preparing architectural drawings, CAD and other computer systems are used to produce many documents related to architecture. And you can do schedules, you can do specifications, you can, just put together your budget, your contract, your code research, your engineering analysis, and, construction management forms. So a lot of different things can be done there, and that can be plotted to PDF, and you can have a large format drawings and like all the information. Or if you want to do your UL sheets or something like that, that will definitely be useful if you use CAD, because it won't be pixelated if you create it in like Word or something and try to scale it up. So that's kind of like another beauty of this program. Usually all the surveys, the U.S. Geological Survey or USGS and other maps, are created using CAD because it's 2D. You don't need to, just do super creative things. There is just basically the information that has a digital map or like aerial photograph with the property lines superimposed, like all those things that can definitely be used. So here also in this textbook, a little bit about BIM is discussed. And that BIM is the building information modeling. So the system uses the parameters that connect drawings with a wide variety of construction documents. So that's, the BIM drawings are created in transparent 3D form, which produces, and also it can change 2D drawings as the design process progresses. So, and you know that a lot of different families can be created using BEAM, but we will talk a little bit about that later. So that was it for our chapter 5. We'll continue our chapter 6 in the next video, and that will start our part 3, which is the basic area design. So in our chapter 6 will be about the environmental design factors. So that was chapter 5. That is it. Thank you so much for watching. I will see you in my next video. Goodbye.